The project, The History of Electrochemistry in the Lab, realized by the students of the chemistry course of the European School of Varese, develops the topic of the history of electrochemistry.
Iron and copper devices of 250 BC, used for the plating of jewelry and the simultaneous production of a weak electric current, were found by archaeologists in Persia and Egypt. Journal of the Electrochemical Society, 1963.
In the 18th and 19th centuries, with Volta and Galvani, electrochemistry evolved with the creation of copper and zinc batteries based on electrochemical processes. In the picture you can see the first dry cell invented by Volta in 1800. It consisted of a zinc and copper disc separated by a sheet of paper soaked in a saline solution. This design made it possible to produce electrical current, but it was limited by its low capacity and durability.
The redox reactions at the basis of electrochemistry, zinc and copper, copper and iron, copper and lead batteries, will be performed in the laboratory, reporting the experimental results of the electromagnetic field produced by the galvanic cells. The experimental data will be compared with the expected theoretical calculations.
This experiment reproduces the ancient copper and iron Persian and Egyptian electrical cell. Two solutions of copper sulfate and iron sulfate with a concentration of 0.1 molar are placed in two beakers. A salt bridge made of paper towels soaked in potassium nitrate connects the two beakers. As a result of a spontaneous redox reactions at the anode and cathode, iron oxidizes at the anode and copper is reduced at the cathode. A current flow of volts is recorded on the voltmeter.
This experiment is based on the redox reactions of Volta's battery. In fact, spontaneous redox reactions concern with zinc and copper. Two solutions of copper sulfate and zinc sulfate with a concentration of 0.1 molar are placed in two beakers. A salt bridge made of paper towels soaked in potassium nitrate connects with the two beakers. As a result of spontaneous redox reactions at the anode and the cathode, zinc oxidizes at the anode and copper is reduced at the cathode. A current flow of volts is recorded on the voltmeter.
This experiment reproduces a lead and copper electrical cell. Two solutions of copper sulfate and lead nitrate with a concentration of 0.1 molar are placed in two beakers. A salt bridge made of paper towels soaked in potassium nitrate connects the two beakers. As a result of spontaneous redox reactions at the anode and cathode, lead oxidizes at the anode and copper is reduced at the cathode. A current flow of volts is recorded on the voltmeter.
As you can see from the table, the most efficient battery is definitely the zinc and copper, which is based on the redox reactions of the Volta battery. This is the most effective way to produce electricity. In fact, it must be considered that the battery used by the ancient Persians was used to plate jewelry, and the production of electricity had a secondary effect. From the table, it can be seen that the experimental data on the electromotive force of the batteries are lower than the theoretically calculated results. In fact, the experiments were not conducted under standard conditions.